atomic number is going to actually give us how many protons are in that nucleus. And so we do have an arrow, yes. So yes, that is going to be 26 protons. So if you look right here up at our periodic table, our element block here. This element block is going to give us 26 right at the very top of the actual element name or element symbol, and that's going to be how many protons we're going to have. Then we need to calculate the atomic mass. Okay, so again, we're going to take a look at the protons plus the neutrons. So we were given the neutrons at 31, and we identified that the protons is 26. So atomic mass. I don't know how to spell today. Atomic mass is going to equal 26 plus our 31 neutrons. And so what are we going to get with that? I do agree. Let me just quickly, because Mrs. Sepulveda is kind of out of it right now. 26 plus 31 is 57. Yes, I do agree with all of you. It is going to be 57 AMUs. Yeah, there we go. All right, so there we go. There is our answer. So excellent job, everyone. Excellent, excellent, excellent. Don't forget your units. That's right. We don't want any naked numbers here. So let's jump over to our social question. Who is your favorite TV character? Jax from Son of Anarchy. I've never seen that show. I really should watch it. I mean, a lot of people say it's really good. I don't know. So nice. Thank you, Anthony. Lee Chang from Kingdom. I think that's his name. Mei Lin says that. Anybody else in the chat box there? Anybody in the chat box? Again, I really don't have a favorite character. Maybe Julie Andrew, or not really, Fräulein Maria from The Sound of Music. Wait till we talk about The Sound of Music. It's great. I love it. So yeah, I don't even know what my favorite character is, but yeah. Excellent, excellent, excellent. All right, so let's go ahead and jump into our schedule. Nice. I see a bunch of people, the Joker, beautiful. So remember, Class Connect sessions are recorded and distributed for learning purposes. Please do not put any personal information or information of others into the chat box for your protection and the protection of others. Please participate. It is important and it is vital for the class. Make sure that you're appropriate when you're participating, and make sure that you're that you're respectful when you're participating. Okay. Attendance is up in the chat box. Remember, the start of the class word is there. We only keep the attendance up for the first 15 minutes of class, so please remember to get your attendance in. You do have until midnight tonight to submit it. So if you are going to wait till later, make sure you copy that word down and make sure that you are actually spelling it correctly. Okay, so a couple of options there. Get it in right now, or you can wait till later on at midnight to get this in. Again, make sure you copy that word down, okay, because we will not give it out again. So the attendance is in the chat box. Again, if you're not sure which teacher you are, try both of them. One of them is going to work. One of them is going to work, all right? So as I do a schedule, make sure you're getting your attendance in and listening in. It is day 15 of our 60-day adventure. It is Tuesday, December 15th. We're going to talk about properties of metals today. We're going to do this all through our Unit 2 element project, looking at the 2F slides for chemistry. So let's go ahead and jump right in and get that opened up. I just do want to kind of draw your attention here to this due date. Remember, this is a tentative due date. Things happen. We need to go over a few things. So this is just kind of a marker for you that we are going to be turning in this project right around January 28th. So don't set this in stone. This is just a tentative. So if we aim for it and we do it, great, but don't be concerned if we are a little later or what have you. Okay, things happen, so we just kind of give this to you as a tentative date. All right, today we're going to identify the characteristics of metals. We're going to explain how atoms lose or gain electrons to create a full outer shell, and we're going to demonstrate this through slides 11 through 16 in our chemistry unit 2 element project. Okay, so make sure that when you do open it up, you're going directly to slides 11 through 16. All right, here we go.
Excellent. So at this point, we need to go ahead and start getting our projects opened. If we have not yet started it, you need to go to your grades tab and download either the Google or the PowerPoint version. The Google version, remember, click on it and click make a copy. The PowerPoint version, remember, just download it. Alternatively, if you want to take screenshots, photos, or notes and download it when you have a little bit more time later, that's totally fine. Here is the link to Mrs. Larkin's grades tab. Here is the link to Mrs. Sepulveda's grades tab. Whichever of those applies to you, open up your grades tab and download the version of the newest project. We are in a new project. You should have already turned in Unit 1. If you haven't turned in Unit 1, that's a big fat 0 sitting in your grade book, so make sure that you get that done because it's worth 85% of your overall grade, and it's impossible to pass if you don't do your projects and don't do them correctly. You got to do them correctly. Uh, it's so cute. Slide 10 we will be doing on the project workday on Thursday, Jadelyn. Okay. That being said, if you did already start your project and you did it in Google, go ahead and open up your Google Slides folder and open up your project that you already started. If you started the PowerPoint version, just open that on your computer and raise your hand. I need raised hands from everyone. We are keeping track of students who are not raising their hands. You have 30 seconds to get your project open and ready to go, or to be ready to take pictures and raise your hand. Go, go, go. Go, go, go. 15 seconds remaining. I have about half of my students with raised hands, waiting on the other half. All right, have not gotten a raised hand yet. Remember, raised hand is in the upper right between the gear and the exit box. I am waiting on Jaden, Eric, Catherine, Omar, Dion, Christopher, Anthony, Monique, Lydia, Adriana, Timothy, Kale, and Aria. Thank you, Canyon. Again, waiting on Eric, Catherine, Omar, Dion, Christopher, Monique, Adriana, Kale, and Aria. Please raise your hand if you're ready to move on. Thank you, Timothy. I appreciate that. Make sure you're raising your hand throughout class when we ask. Waiting on Eric, Catherine, Catherine. Are you there? Omar, Dion, are you there? Please raise your hand. Christopher, Monique, Adriana, Kale, Aria. Please raise your hands. I'm going to screenshot a picture of people who have not yet responded. Please respond. Raise your hand. If you can't raise your hand, tell me in the chat box that you're good. Oh, sorry. Your hand, Omar. Sorry, I wasn't looking at the chat. Your hand, Omar, is in the upper right of your whiteboard. Yeah, so you can see Mrs. Spulvita pointing at it right here. It's between the gear and the exit button. So just look in the upper right. Perfect. Thank you. Sorry, looking again at our participants. All right, going to screenshot a couple of people. Hi, Stephen. Welcome to class. Please go ahead and open up your project. Perfect. All right, let's go ahead and move on. Again, if we don't see you responding over multiple tries, we will be checking in with you. No worries. Glad you're here, Stephen. All right, let's go ahead and move it along. So for your project, all right, we are going to be taking a look at a element on the periodic table. Now you can only choose one of the elements that is boxed in red, all right, so you can see them right here. Boxed in red. The reason we're not choosing some of these is because some of these ones in the middle kind of act a little bit weird, and the ones on the bottom don't have very many common uses in everyday life. And you'll notice that one of your slides, I think it's like slide 33, asks you about how your element is used in real life, and so that's why we don't want to use some of these that aren't used very often in real life. All right, so you'll be choosing one of these elements in red, and then that's what you are going to be committing to for your project. Oh, yes, there you go, Omar. Glad you figured it out. Let's go ahead and then take a look here. For your project, you need to tell me which element did you choose and why. Your reason why can be very simple, just like, I thought this was an interesting element, I've heard of this element, I haven't heard of this element. Whatever reason that you want to choose is totally fine, as long as it's one of the elements that we asked for. Then you need a photo of your element square on the periodic table. You should get this from ptable.com. Basically, ptable.com is your best resource in this course, and especially for this project. So you can just click on it and then grab a picture of it, of the big square that pops up. The cool thing is you can also click on the name in your big square that pops up, and that'll open the entire Wikipedia page, which will make research for the later slides really easy for you. Yeah, so definitely use this periodic table. Use that as a resource. You also have a slide that asks for a picture of the Bohr model. For this one, all you need to do is Google your element with the word Bohr model. So for example, if you were to choose carbon, which you're not allowed to choose because that's not one of them, but you could just Google carbon Bohr model, and a picture of the Bohr model would pop up. Again, this is all project stuff, so I will be posting a recording on Thursday of step by step all of the project slides that you should be able to do so far. So that's like the intro project slides, that's slide 10, slide 17, and I think slide number 22 you should be able to do by Thursday. So I'll post a recording with step by step. But if you want to get started early, challenge yourself, get it done out of the way. I totally am all for that. I want to do whatever best for you, and I don't want you to stress out. That's why I'm giving you info now. That way you're more prepared on Thursday. Okay? Yeah, exactly, Shelby. So where are valence electrons found on the atom? You should already know this from last week. Valence shells are always found on the outermost shell. All right, so that's actually the answer right there. I'm giving you the answer right now. They are found on the outermost shell of the atom. And again, your Bohr model will show you all of the electrons in all of their shells. So then you'll just look at the outermost shell and you'll count how many valence electrons do you see there. Right, so that's that slide, easy peasy. Again, more instructions to come on Thursday if you don't yet feel comfortable doing it by yourself. Either way works, okay? Now, let's go ahead and actually practice it though. So let's take a look at magnesium. So we want to know how many valence electrons on the outermost shell does magnesium have. First, grab your whiteboard pointer tool, your colored pointer, and point for me where is the outermost shell of magnesium. Point for me where is the outermost shell. Outside shell, outermost shell, point to the outermost shell. I got 3 people up there, need more people up there. Grab your colored arrows. That's the arrow with the little star next to it. You have 2 arrows. Perfect. There we go. Lots of people. There we go. Looks like we're pretty unanimous and agreeing up there. Beautiful. Let me pause those tools right there. And erase a couple of those. All right. So yes, the outermost shell is going to be this one right here. So we're going to ignore everything in the center for now. All right. Because really, I mentioned last week that the outermost shell is the most important. So count them up. How many electrons do you see on that outermost shell? Tell me in the chat. How many electrons do you see on this outermost shell, on this valence shell? Thank you, Shelby. I need more participation in the chat. Thank you, Miles. Thank you, Stephen. Thank you, Camilla. Malin. Yeah, you should easily be able to count 1, 2. So there are 2 electrons right here for magnesium. Magnesium has 2 valence electrons. Let me drag this over here. Beautiful. Now, that being said, if we know it has 2 valence electrons, then what group number is it in? Remember that we learned these last week that the group numbers are related to the number of valence electrons. So tell me in the chat box, what group is it therefore in? Thank you, Shelby. Thank you. No worries, Stephen. More people in the chat box. Based on our chart here, based on what we learned last week, if it has 2 valence electrons, what group number must it be in? If it has 2 valence electrons, what group number is it in? Thank you, Annabelle. Thank you, Camilla. Thank you, Daniel, Malin. Yeah, exactly. It's going to be in group 2. Group 2. All right. And that being said, what is the name of that group? What is the name of that group? Again, take a look at our chart. I want you to get used to using these names. We'll have an entire lesson on group names, but let's go ahead and get started on getting used to them while we're at it. There we go. Thank you, Shelby. Thank you, Camilla. Thank you, Daniel. Be careful. Group 1 and Group 2 do have similar names, but we're looking at Group 2. What's the name of Group 2? Please type it out. I know you're like, why am I typing it out? I see it on the board, but that's because you need to practice using it. You need to practice the name. Yeah, exactly. So this is actually going to be the alkaline earth metals. All right, so let me go ahead and type this. It's going to be the alkaline earth metals. And let me move this to where it belongs. There we go, alkaline earth metals. Now, please note that, remember last week I mentioned that there are 2 different ways that we call these groups. We now call them groups 1 through 18. Those are what are called the IUPAC names, which are the standard names that we use now. But they did used to be called the A and B groups. So remember that if you take a look here at our periodic table, these big groups used to be called the A groups, and these small groups used to be called the B groups. Timer's going off. All right, Mrs. Sepulveda is going to send out the links to the attendance and the start of class word one more time, and then we will be erasing the chat. So get your attendance done now, otherwise you will miss the attendance from the chat. Okay, so these big groups are called the A groups. The small ones used to be called the B groups, but now we just call them groups 1 through 18. But again, sometimes people still use the old group names. Either way, though, you still know how many electrons are in them. Group 1 has 1 valence electron. Group 2, they all have 2 valence electrons. Group 13, take a look at the ending number. They all have 3 valence electrons. Group 14, they all have 4. Group 15 all has 5. All the way to group 18, they have 8 valence electrons. Emoji in the chat box if that makes sense. So you can still identify how many valence electrons each atom in this family has by just looking at the last number. Smiley or emoji if you understand. Beautiful, beautiful. All right, so that being said, how many valence electrons do most atoms actually want? Go ahead and tell me in the chat box. Remember, it's called the octet rule. Think about the word octopus or the word octagon. What does oct mean? How many valence electrons do atoms want? So Shelby, again, the B groups, I mentioned this last week, but these B groups, groups 3 through 12, they have weird rules. So a lot of these actually only have 2 valence electrons. All of these, they might have 2 or 3 valence electrons. They're just all kind of weird ones, so that's why we're not choosing them for our project. Transition metals are something that you learn about in a more advanced course. Perfect. Okay, so taking a look here. Yeah, most of them want 8 valence electrons. Remember, the word oct means 8. So most of them want 8 valence electrons. So if you take a look at that, then is magnesium stable? If it only has 2 valence electrons but wants 8, is it stable? Yes or no? Tell me in the chat. Is it stable? Is it happy? Yes or no? If it only has 2 but it actually wants 8, is it stable? Is it happy? No, it is not. All right. So that's something that we need to fix, and we're going to go over in a few moments how this gets fixed. Here we go. This is going to be the answers to slide number 11.
All right, so let's take a look at that slide. At those answers here. How many valence electrons in the outermost shell does magnesium have? We're going to go back to that previous slide to help you out. Therefore, what group or column is that magnesium in? Group number, make sure you type it out correctly, all of it. Don't give us any shorthand. Correctly type it all out. And now obviously recall how many valence electrons do most atoms want. What is that octet rule? Just think of octopus. Okay, how many tentacles does an octopus have? Is magnesium stable? So we're going to go back to that. This is on slide 11. Slide 11. Raise your hand when you are finished filling this in. We're going to give you, let's see, about a minute to do this. A lot of information. Here you go. Go, go, go. Maybe less than a minute because you guys are moving. No, you don't need to box the no in the yes or no area. Just delete the yes. That's all you need to do is just delete the yes. Okay. You don't need to box it in. Just delete it. Seconds, 25 more seconds. They haven't raised their hands yet, so 15 seconds, 15 seconds. Dion, Christopher, hand raised, Monique, Lydia, Adriana, Angel, thank you so much. I'm seeing some people raising their hands. Thank you, thank you, thank you. Dion, Christopher, Monique, and it keeps moving on me. Omar, Dion, Monique, Lydia, Angel, Kamari. Thank you, Kamari. I just saw your hand raise. Ira. Let's get our hands raised. Ira, Angel, Lydia, Monique, Dion, and Omar. Thank you, Omar. Excellent. Beautiful job. Thank you, Angel. Thank you, Kamari. Excellent. All right, let's go ahead and move on. Perfect.
Sorry, I'm just private chatting a couple of people that we haven't heard from. Again, we do need to hear from you, so I'm still waiting on a response from... Okay, thank you, Christopher. Yep, you're all set. Thank you. I saw your response. Thank you. I appreciate it. Still waiting on a response from Dion, Monique, Lydia. I'm going to private chat you. And again, we do need your response, so please, please, please respond. Who else am I missing? Angel, need your response. You're my last person that we have not yet heard from over multiple attempts. You do need to be here. You do need to be participating. Cool. All right, everybody. So let's go ahead and actually figure out, what do we do if they're not happy? How can we make them happy? So let's take a look at calcium. Calcium is actually a lot like magnesium. It also only has 2 valence electrons. So here we go, 1, 2. All right, so based on this, remember, they want 8 in total. They want full valence shell. So what do you think? Is it going to be easier for calcium to gain 6 more electrons, gain 6 more, or to just lose 2? What do you think is going to be easier, to gain 6 more or to lose 2 electrons? Tell me in the chat box. All right, just in terms of straight numbers, is it easier to gain 6 more, to fill the current shell, or to lose 2 and drop down to a full shell? Awesome. I see an answer from Stephen, Shelby, Kamari. Just in terms of numbers, is it easier to gain 6 or lose 2? Gain 6 or lose 2? Yeah, it's going to be a lot easier to actually lose 2. All right, so let me go ahead and type this up here. All right, so it is much easier to gain 2 electrons, to lose, oh my gosh, to lose 2 valence electrons and drop down to a shell that is already full. All right, so they take advantage of this. Calcium is going to take advantage of this and just try to lose its few electrons that it has. Now let's take a look at selenium. Selenium's over here on the right. Selenium has 6 valence electrons. So again, we're going to ignore the center. It has 6 valence electrons. So this time, is it going to be easier for selenium to gain 2 or lose 6? Gain 2 or lose 6? What is easier for selenium? Thank you, Shelby. Thank you, Jadelyn. Thank you, Bryce. Yes, so selenium is going to actually do the opposite. So for selenium, my tools are being so ridiculous right now. All right, let me try this again. All right, so for selenium, oh my gosh, dumb tools. Here we go. Nope. Let's try again. All right, so selenium, it's going to be easier to gain 2 more valence electrons to fill the current shell. All right, so what you might be noticing then is that these 2 atoms actually want opposite things. Calcium wants to lose 2 electrons, selenium wants to gain 2 electrons, and here's what happens. They can actually work together. So we can send over this electron and send over this electron, and now calcium has lost the 2 it doesn't want, and selenium has gained the 2 that it needs, and everybody is happy. This is called bonding. So by sending over electrons, they are now stuck together and bonded, and it becomes a perfect marriage. They're happy, they're in love, and they are bonded together, and everybody is stable and happy. All right, so this is called bonding. Today we're going to be specifically taking a look at metals that prefer to lose electrons. So when you look at the periodic table, you'll notice that most periodic tables are labeled by colors, or are color coordinated. And so they will show you that some of our elements are metals, which tend to lose electrons until they go down to a full shell, just like the calcium we just saw. Some of them are nonmetals, like on the right. They try to gain electrons to fill their current shell, like the selenium we just saw. And some of them are metalloids, which are kind of the staircase elements, we like to call them, or the ladder elements. So those ones will actually have properties of both metals and non-metals. Now, the cool thing is that you will need to identify for your project if your element is a metal, non-metal, or metalloid. But the great thing is, if you take a look at ptable.com, all right, so again, I'm going to show you ptable.com. In a moment, Shelby, give me a second. So ptable.com, if you actually click where it says metals, metalloids, and nonmetals, it'll highlight all of them for you. So you just need to click on metals, metalloids, nonmetals, and when yours is highlighted, that tells you what group it is in. All right, so you will need to know that. Again, I will give more instructions on Thursday if you don't yet feel comfortable doing that yourself. So for most atoms, remember that based on our octet rule, a full valence shell has 8 electrons. But take a look here. Helium, neon, argon, krypton, xenon, and radon. We have pictures of them down here. All have full valence shells. Notice helium only has 2 electrons on its valence, but that's because the smallest shell we mentioned last week can only fit 2. The rest of them do have 8 valence electrons. So if they are all happy and stable, do you think that they will bond with any other atoms? Yes or no? Do you think that these happy, stable atoms want to bond with anybody else? No, they are happy being single. Now, these are called the noble gases. And if you think about like olden times, nobility did not like to mix with the commoners, and noble gases are very similar in which they do not want to bond with anybody else. Awesome. All right, but today we're going to be taking a look at metals specifically. We'll take a closer look at noble gases tomorrow. But metals want to lose electrons. They want to lose electrons. Now, the reason is because they only have a few valence electrons. We just saw multiple examples of this. Metals generally only have 1 to 3 valence electrons, and so it's much easier for them to just lose those 1 to 3 valence electrons and drop down to a shell that's already filled up. So an example here is sodium. Sodium will give away its 1 valence electron, and take a look here. Now it has a full shell right underneath. Metals are also malleable, which means that you can pound them into sheets. And they're also ductile, which means that you can stretch them into wires. So taking a look here, metals have really, really important properties that allow them to be used in everyday life. So for example, malleable copper can be used as a bowl, and when you make it stretched into a wire, it can also be used for the wiring in your house. Now, metals are able to be ductile and malleable because their metal atoms can actually roll over each other without breaking connections with each other. So a lot of other substances, when you try to stretch them or you try to flatten them, they just crumble because they don't maintain their connections with the other like atoms around them. But metals are really good at keeping connections with each other. It's a lot harder to break apart metal atoms from each other. Okay, emoji in the chat box if you feel comfortable with this. Metals want to lose electrons. That's the most important characteristic, but they also have some other really unique properties like being malleable and ductile. Awesome. Here we go. This is going to be the to number 13.
You're going to notice at the very top that metals are what? And we're going to go back to that. Metals are want to lose electrons. They have 1 to 3 valence electrons, and they can go back and go down to a full shell by giving away these extra electrons. Now, metals are malleable. Okay, remember we can pound them into sheets. We can make a bowl out of them. We can make a wire, so they are, if we go back, they are ductile. So there you go. Here are your words. Lose at the very top. Metals lose electrons. Metals are malleable, and metals are ductile. Right there where the green, where the yellow highlights are, I'm going to give you 45 seconds up on the clock. Hands raised when you have that. Hands raised. Let's go. Go, go, go. 45 seconds up on the clock here. 18 seconds up on the clock. 18 seconds up on the clock. Again, even if you are doing the alternative method, meaning taking screenshots, writing pen and paper, or actually taking pictures, make sure you still raise your hand just so that we know that you're with us. So looking for Patrick, Adriana, Timothy, or Tim and Kale. So Patrick, Adriana, excellent. Patrick, Kale, Ignacio. Ignacio, I know your hand was raised. Go ahead and keep it raised. Keep it raised. All right. Thank you, everybody. That's 100% participation. Awesome job. Let's go ahead and continue on. And
All right, let's go ahead and try to actually practice this now. So which of the following atoms is a metal? Remember, metals want to only have a few valence electrons, and they want to lose them. So things you need to notice, we're looking for metals that only have like 1 to 3 outermost electrons. Again, that means they only have a few valence electrons, and it's much easier for them to lose them. Grab your whiteboard tools and either point or box for me which of these is the atom with the with the least electrons that it will want to lose. Point or box for me on the board. Which of these 3 options has the least amount of valence electrons that it wants to lose? Uh-oh, where'd our tools go? Sorry, get those back up on there. Perfect. Good, looks like we are agreeing here. Shelby, this is not the one that you need to do in your project. We're doing a practice problem first. So don't do slide 14 until we tell you to do slide 14. Yeah, okay, no worries. All right, so let me go ahead and pause our tools here. Looks like we all agree absolutely the correct answer here is A. All right, so this is Na. Na is sodium. So Na is the abbreviation for sodium. And this is one that we actually already looked at. So sodium only has one valence electron. Ooh, that's big. There we go. We're going to ignore everything in the middle. It only has one valence electron. And so it's much easier for it to lose one than to have to gain 7 more. It's going to lose one, drop down to a full shell. That makes it a metal. That makes it a metal. Go ahead and give me an emoji in the chat box if you feel like you can do the next problem on your own, because this is an example just like slide 14. For slide 14, again, we're going to be looking for atoms with few valence electrons, 1 to 3 outermost electrons. Awesome. I see Annabelle, I see Stephen, I see Camilla. Emoji if you feel like you can do the next one on your own. You just need to identify an atom with only a few valence electrons. That will be your metal. Okay, no worries. Stephen, if you need help, we'll be in the Q&A area. All right, let's go ahead and try slide 14 on our own.
That off. So please no answers. Please no answers. Here we go. If you need help, always use that Q&A. You always use that Q&A in the chat. So which of the following atoms is a metal? Remember, metals only have few valence electrons. Remember, we're talking about 1 to 3 valence electrons in the outermost shell. So they want to lose. So kind of look at these. Which has the fewest? Which has the fewest valence electrons? Again, we're talking 1 to 3 in the outermost shell. Go ahead and mark an X. Is it A, B, or C? If you have any questions, please let us know in the room chat. We're going to only give you about 45 seconds to complete this. 45 seconds. Go, go, go. Raise your hand when you are finished. Raise your hand when you are finished. We're looking for the fewest valence electrons. The fewest valence electrons that they want to lose. All right, here we go. So looking at this, Catherine, Omar, Taylor, Adriana, Tim, Derek, Kale, Alexis, Kamari, and Angel, let's get our hands raised. I give you plenty of time to work on that. So let's get our hands raised. Again, Catherine, Alexis, Catherine, Tim, let's get our hands raised. Excellent. Let's go ahead and move on. Perfect. Thank you so much.
All right, so a couple other extra properties that we should know about metals is that they are excellent electrical conductors, which makes sense. All of our electrical wires are made of metal internally. And the reason why is because metals have electrons that can flow freely throughout them. And anytime that you have moving electrons, that is what electricity literally is. All right, it's literally what electricity is. So if we have freely moving electrons, we have electricity. That actually also makes them very good heat conductors, because those electrons can actually pick up heat from one side of a wire or one side of a metal and drag it on over to the other side of the metal. So that's why, for example, all of our pots and pans tend to be metal, because metals are so good at carrying heat. All right, we wouldn't make a pot out of like wood, because first off, if you're using an open flame, it would probably catch on fire. But second off, if you're not using an open flame, if you're just trying to heat it up, it takes a long time to heat up, and it would take a long time to heat up the food inside. So often we'll use handles of wood, because those ones won't heat up as fast, and so they won't burn us when we grab them. Because I don't know if you've ever grabbed a metal handle, but it's not fun when it's hot. All right, so they are good at both electricity carrying as well as carrying thermal heat energy as well. And these will actually be the answers to slide 15.
Electrons flow freely, carrying electricity. And then obviously metals are good heat conductors. Fast-moving electrons move and pick up heat energy, or thermal energy is another way to say it. Thermal energy, then transfer the heat energy very quickly. So these are the answers to slide 15. I'm only going to give you about 30 seconds to get these in. There's only 2 answers. Easy enough. 30 seconds up on the clock. Go, go, go. We do have time that our time is running short, so let's go ahead and go freely and thermal on slide number 15. Go, go, go. Few people again, we have to work quickly around here. Omar, Taylor, Patrick, Christopher, Adriana, Tim, Derek, Kale, Canyon, Ira, Kamari, Angel, and Ignacio. Get your hands up there. Hands up. Hey, excellent. We're moving now. Taylor, Christopher, Kamari, and Ignacio. Let's get our hands up. That's okay, Angel. That's okay. Just let us know, and then you can go back and continue typing, okay? Christopher and Kamari. Christopher and Kamari. All right, let's go ahead and move on. We do have more stuff to get through.
All right, perfect. No worries, Taylor. Thanks for letting us know. So, metals, the last thing we need to know is that metals are lustrous. They have what's called metallic luster, which means that they are shiny. And just like the crab in Moana loves shiny things, so do humans. That's why metals have been used throughout history in jewelry, because they are so shiny. Yeah, excellent. Exactly, Angel. That's what we want for you. Make your life easy, take pics. All right, so some metals do have more metallic luster than others. So, for example, gold, silver, and platinum are very commonly used for jewelry because they're very shiny, as well as they don't rust, and as well as when you heat them, you can change them into any shape that you want because of their malleability and their ductility. Now, mercury is actually also very shiny and lustrous, and you'll see here mercury is the only metal that is not solid at room temperature. It's actually a liquid, but the reason we don't use that as jewelry is because A, it's a liquid and it would melt off of you, and B, mercury is also toxic if you ingest it and if you play with it too much. So people in like 50 years ago used to break open mercury thermometers and kids would play with the mercury, but we learned over time that mercury is toxic, so we don't have mercury thermometers anymore. And this is also why you shouldn't eat too much fish. A little bit of fish is good for you, but if you eat too much fish, fish do have a tendency to build up mercury in their bodies, which if you eat too much can also build up in your body. All right, yeah, no good. A little bit of fish, again, is really healthy for you, but too much can be bad for you. All right, so metals are shiny and metals are all solid except for mercury. Here is your answers to slide number 16.
Which means they're shiny, like shiny things. Mrs. Holden loves shiny things. And metals are always solid at room temperature except for mercury. So again, shiny and mercury. We'll go back to the last slide. Again, we'll give you about 30 seconds to pop that into your notes. 30 seconds to pop that into slide number 16. Go, go, go. Hurry, hurry, hurry. Let's work hard. Yes, raise new hands. Sorry, we forgot to lower our other ones. So shiny and mercury. 15 or 12 seconds, 12 seconds up on the clock. Again, if take a picture, screenshot it. If we're going way too fast for you, just make sure you take a picture, screenshot it. We will or you can always come back to the recording. So let's go ahead and check in. Taylor, Christopher, Shelby, Adriana, Tim, Alyssa, Kale, Ira. Thank you, Ira. I saw you're going up. Beautiful. Adriana, Tim, Kale, Angel. Adriana, Tim, Kale, Angel. All right, let's go ahead and move on. Time is a-wasting.
All right, so again, we will give you some more instructions for all of the project slides on Thursday, but at this point, if you want to do slide 17, feel free to do so because that way it's off your plate. Phew, easy peasy, less stress. You can do all of this at this point. So what group is your element in? Again, you can see the group number on ptable.com. I will send that link to you for the 1,000th time because again, it's such an important link. So look for your group number and then go ahead. If you click on that group number, you can actually also find what the name of it is. So if you click on it, you can also find the name of that group. Therefore, based on your group, how many valence electrons does it have? Again, look at the end of the group number. Group 1 has 1 electron. Group 2 has 2 valence electrons. Sorry, I should say valence, outermost. Group 13 has 3 valence. Group 14 has 4, etc., etc. To be stable, then, how many valence electrons does your element want to lose or gain? Remember, this goes back to the octet rule. If it only has 1 to 3, it's going to want to lose 1 to 3. That's easier. If it already has 5 to 7, it just needs to gain 3, 2, or 1 more to be full. All right, so go back to your octet rule. And then again, use ptable.com and identify, is it a metal, non-metal, or metalloid? Again, you can just click where it says metals, non-metals, and metalloids. That'll highlight all of them for you on the periodic table and just figure out when does your element get highlighted, and that will help you identify exactly what it is. Easy peasy. Again, don't freak out if you don't have time to do it now. You'll have more time on Thursday. But I want to give everyone the opportunity to work at whatever pace works best for you. But you do need to work on it because, again, projects are 85% of your grade. There are only assignments in class. You cannot pass by doing attendance. That's just not possible. All right, let's go ahead and wrap this on up.
And looking at that octet rule. We did this all through slides 11 through 16. So let's go ahead and stop right here. Let's stop our recording.